Here. So what I have right here is pork suet infused venison V11. This is my final plate of sin agar. It has grown bacteria really well. I waited until the expiration date almost, like 10 days before, and I used homemade cultures and did cold enrichments to try to enrich the quantities of certain species of bacteria within it. Y enterocoelitica particularly, which is what this is designed to isolate, or Aeronomus. So I isolated this from pork suet infused venison burger meat using sin agar cultures and cold enrichment tactics. So here are some facts about the bacteria, and then I'll tell you what it could potentially be. The bacteria is indole positive. The bacteria synthesizes aromatic indole chemicals, which in low concentrations cause the culture to have a flowery smell when there is small amounts of bacteria, but the more bacteria, it turns into a sicky sweet smell and then a smell like feces or rotting fish. This is characteristic of the chemicals known as indoles, and this bacteria synthesizes indoles because of that. So it also has a cold temperature affinity. I grew many bacteria cultures in the refrigerator, and Y enterocoelitica grows faster than almost any other species of bacteria at refrigerator temperature, and it can take over an entire culture within 2 to 3 weeks in a refrigerator. The bacteria also exhibits low pH survival/proliferation. The bacteria survives and reproduces in a low pH acidic environment. The coffee culture that I made out of coffee had a pH between 4 and 5, which is somewhat acidic. Sin agar. So on sin agar, the bacteria, if I can see the side, the bacteria produces red bullseye colonies, or at least there are some red bullseye colonies in here. And what that means is that it ferments mannitol, which is the only sugar in this culture. Mannitol, only Yersinista, Aeronomus, and E. coli 0157H7 have the ability to ferment mannitol into acid. Bile salts. The bacteria survives within cultures that I cook up infused with bile salts and crystal violet dye. Bile salts and crystal violet dye are two chemicals that are highly toxic to gram-positive bacteria, but not very harmful to gram-negative bacteria, meaning that whatever bacteria is growing in here is gram-negative. Gelatin culture liquefaction. The bacteria digest gelatin, causing gelatin cultures, like this one, to liquefy. Many species digest gelatin. However, E. coli species do not dissolve gelatin, but Aeronomus hydrophila does, and so do some strains of Yersinista enterocoelitica. So let's just go over. However, there is one other species of bacteria that exhibits all of these characteristics other than Yersinista. Aeronomus hydrophila and Yersinista enterocoelitica. So indole production. So isolate X produces indoles. Yersinista enterocoelitica, certain strains do produce indoles. In fact, most strains do, but some strains don't. Aeronomus hydrophila, all strains do. Cold temperature affinity. So isolate X exhibits cold temp affinity, and so does Y enterocoelitica and A hydrophila. Low pH survival. pH 4 to 5, Yersinista enterocoelitica can survive and breed in pHs as low as 4.3, and Aeronomus hydrophila can survive and breed in pHs as low as 4.5. Gram negative. Sin agar / mannitol fermentation. This bacteria exhibits that, and so do Y enterocoelitica and A hydrophila. Those are the only two species. Gelatin digestion. Yes, most strains of Y. enterocoelitica do, and all strains of A. hydrophila do. So you might be wondering how I am going to tell if this bacteria in here is Aeronomus hydrophila or Yersinista enterocoelitica, because these agar cultures are actually used for isolating Aeronomus species as well. But you might be wondering how I'm going to tell. There is something known as the urease test, and the urease test is one of the ways that that is one of the few ways that I can differentiate whether or not which species this bacteria isolate is. So yeah, hope you enjoyed and see you in the next video.